You can create a bitmap index, or you can create a B-tree index. To create a B-tree index, you simply leave out the bitmap option, and you can create a B-tree index as a unique index. In terms of accessing small numbers of rows, namely a single row, it's much faster to create a unique B-tree index if you can. Obviously, you need unique values on the index column values, either single columns or composite columns, in order to create a unique index. You cannot create a unique index unless you actually have unique values. To create a bitmap index, you simply type create bitmap index, and etc. etc. Remember, you can't create bitmap indexes online. An online index creation essentially generates the index file or the index structure into temporary table space and then copies the index back into the original index when the index has been created. Effectively, what happens is that any DML activity on that index whilst it's being generated will not be disrupted. That's the objective. Not using the online option and creating an index offline simply dumps the index and recreates it. Now, something funny I saw in an early version of Oracle 8 is that I had an index that generated and the disk ran out of space. What happened was it created half the index, and then somewhere along the way the application started trying to access the rows that were not indexed since they had been missed because the disk ran out of space. Even though the rows existed in the table, the optimizer decided to access the index in the table rather than just the table, and therefore it actually couldn't find the rows. As far as the application was concerned, the rows did not exist, but was actually incorrect. So be careful using creation of indexes and creating them in offline mode, particularly where you're going to end up running out of disk space. In fact, that would probably apply to an online index creation as well, apart from the fact that if the index creation did not succeed completely, then the copy would probably not occur. Compression of an index. Compression simply takes prefix columns, in other words leading columns in multiple column indexes, commonly called composite column indexes, and removes duplicate values, effectively creating a tree of the index values themselves in addition to the branch levels in a B-tree index. It can be very efficient for reading the information because you effectively compress more indexes into one block. Obviously, you need to read more than one index in order to make that relatively efficient. However, when updating, inserting, or changing, insert, update, or delete, changing rows in the table, you can actually cause a slight performance impact by the fact that every time a row is inserted, it needs to recalculate how the compression sets up and reorganize the tree, etc., etc. A little bit slower, but I haven't noticed any serious problems. No sort is an option allowing you to create an index a little more rapidly, and it will only allow you to create an index in no sort, implying that the index does not need to be sorted, only allowing creation of that index in no sort mode when the table is physically sorted in that order. In other words, the rows have been inserted into the table in the order required by the index. This type of thing commonly happens in batch operations or data warehouses where tables are cleared down and then reinserted completely. SQL Loader will do that kind of thing. A reverse order index is actually an index where the values within the index columns themselves are actually stored in reverse. In other words, 1, 2, 3 is stored as 3, 2, 1. It's not a descending index as some people tend to confuse it with. The obvious implication is you cannot create a no-sort index with the reverse option because it doesn't apply. Reverse index is simply not sorted. It's sorted in reverse order. The reason why a reverse index is created is in order to place rows which are using sequential key values, which would normally place the rows in the same block. What you want to do is place the rows in separate blocks because the index column values are placed in the blocks based on the index values, based on the B-tree structure. This is typically used in very highly concurrent environments with very heavy insertion activity, typically Oracle RAC installations and very highly concurrent OLTP databases. I have not found any advantages using reverse indexes in minimal or moderate types of concurrent environments. The parallel option simply allows you to create an index in parallel. Make use of multiple processors on a multiple CPU platform, and it can be quite a lot faster.